Assalamualaikum warahmatullahi wabarakatuh. My name is Akmal Haziq bin Muhammad Dum. My ID is 18002309. I'm from Mechanical Engineering 1, and this is my lab presentation for lab number 2, Fluid Mechanics 1, January 2021. So, table of contents. Firstly, I will go to the introduction of the experiment, and then we will go to the objectives, theory, methodology and setup, results and discussion, and then conclusion. So, introduction. Bernoulli's principle state that when the velocity of the fluid is high, the pressure is low. And the Bernoulli equation is derived from the concept of conservation energy, where energy cannot be created or destroyed, but it can only be transformed in different forms. So, which means that total energy initial will equal to total energy final. And there will be a few assumptions made in this experiment, which is the fluid flow in steady flow, the fluid is incompressible, and there should be no losses from the fluid friction. So next, the objective. The objective is to verify the validity of Bernoulli equation. And what is the equation? So this is the equation. P, which is the fluid pressure, divided by ρ, which is the density, plus V square, which is the flow velocity squared, divided by 2, plus G, which is the gravitational acceleration, and Z times with Z, which is the height vertically. And this equation should be a constant, which means in every point in the fluid flowing in a tube, for example, we can apply this equation. And if we divide the equation with G, we can get P1 over divided with rho G plus V1 squared divided by 2G plus Z1 will be equal to P2 divided by rho G plus V2 squared divided by 2G plus Z squared. In this experiment, there will be no height vertically, there will be no difference in height, so Z1 will be equal to Z2, therefore we can ignore the Z component here. So we will left with this equation, P1 over rho G plus V1 square over 2G equals to P2 over rho G plus V2 square over 2G. So we know that P1 equals to rho GH, so we will get the H1 equals to P1 over rho G. So note that this P1 equals to rho G and P2 equals to rho G is the same. So we can replace this element with H1. So we get the equation H1 plus V1 square over 2G equals to H2 plus V2 squared over 2G. Thus, if we replace the 2 here with n, we can get the height at any point equals to height 1 minus Vn square divided by 2G minus V1 squared over 2G. And note that the V, the velocity, equals to flow rate over area, and flow rate is equals to the amount of volume flow in terms of second, which means how much fluid flow in volume in how many seconds. Next, the methodology and setup. So the setup consists of air bleed valve to let the air in the manometer tube flow out, and unions which stick this test section with the water inlet and water outlet, and adjustable feet to make sure the apparatus is level, and a bucket here. So, firstly, place the ventimeter onto a horizontal surface and note the height of input valve and output valve and make sure they are same. Attach the apparatus with the power supply but keep the supply off. Open all the air bleed of the manometer present at the top. Turn on the power supply to run the pump and adjust the flow rate control valve until water level in all manometers is at readable range. Place stop plug in the basin to avoid the water from flowing out of the basin. Note the time required to fill the basin with a specific amount of water. For example, how much time required to fill 6 kilogram of water, which is 6 liter of water, and then remove the stop plug to drain out all the water from the basin, and then place the dynamic pressure probe with the static pressure port and measure the manometer data from both of the probes. Now place the dynamic pressure probe with the next static pressure probe and measure the manometer data from the probes. Repeat the above steps for measuring data from all the manometer probes. Turn off the pump and set off the power supply. And after getting the results, after getting the data from the experiment and applying to the equation earlier, we can get the results. And then we can see here that the diameter is decreasing from A to D because the test section is gradually getting smaller in diameter, and then from D to K it is gradually increasing in the diameter. So we can see obviously the area will decrease and then increase, and then this is the distance of manometer B from A, manometer C from A, and etc. And we can see here for 6 kilogram of water, to get 6 kilogram of water we need 13 seconds of time, so we get the flow rate of 0.000458891 meter cube per second. And from that we can apply to the formula to get the rest of the data. So we can see here that the height of the experimental value is decreasing until D, and then it started to increase again until K, and the velocity is increasing until D and then start to decrease until K. You might not see here, but I will try to make it clear later. And then we can see that the height is decreasing because the velocity is increasing. So when the velocity is increasing, so the pressure of the water decrease. So the atmospheric pressure will be relatively greater than the previous hydrostatic pressure. So we can see a trend of decreasing of the water level. And after point D, the velocity start to decrease, so the pressure start to increase, and that's the increment of the pressure here. But the pressure after point D is not equal to, the pressure at point K, which has the diameter same as point A, is not equal because there are losses in energy, and that is the assumption made. So discussion from the result, we can see clearly that the velocity increases when the diameter of the tube decreases. Moreover, we can see that the pressure decreases at a smaller diameter tube as the velocity is higher. The experimental height after the smallest part is smaller than the theoretical value because there is energy loss. Conclusion from the results and discussion above: the Bernoulli equation is verified, which is true, and Bernoulli's principle is therefore true. When the fluid flows from larger area to smaller area, the velocity increases, thus the pressure decreases. The assumptions made clearly affected the result as a lot of energy is lost due to friction. And that's all from me. Thank you.